We'll go for it.
Okay. All righty. Whoops. Well, I'm good to see you, everybody. If you don't know me, I'm Chad. Um, I work at a company called Convoy, which is a digital freight technology startup. Although it's probably too big to be called a startup at this point. So we did our Series E in January of this year. So the interesting thing about Convoy is that they don't have a massive volume of data, but the data that they do have is like the business itself is pretty complicated. I would say. So like if you were planning out a traditional like entity relationship diagram, you would have hundreds of entities, like different types of, like you have like contracts and you have shippers and shipments and like fulfillments and stops and like all of these things. So extraordinarily complex data, and it's been very different for me personally because I came from Microsoft. I was on the artificial intelligence platform team there, and we worked with enormous volumes of data, being Microsoft Office. So the main problems we were trying to solve were all compute cost related. And I realized something when I was working at Microsoft, which is that a lot of the technologies that are adopted, the data startups that sort of come out are based on these, the problems that extraordinarily large scale tech companies have. And a lot of those problems did not apply to me. So I just thought that was super interesting. But anyway, a little bit more about me is I am a 2 times junior Olympian in Taekwondo. I've won gold both times. I'm also a national champion and at Taekwondo. It's a life that's far behind me now, but old days. And then I've also done a couple other interesting things. Just talking about this, but I'm a creative writing major. I used to be a journalist. And then I actually co-produced a reality television show in China called Raymond Guanjin, which I'm probably butchering the pronunciation of. It meant the People's Champion. It was a sports show. So moving on here, a little bit more about Convoy. It's founded in 2015. It's the world's first digital freight brokerage. So the whole idea is like the freight brokerage space is really legacy and complicated. So you, on one side of this marketplace, you basically have the shipper, some company that's trying to move some freight, like Walmart or Starbucks or something like that. And then on the other side, you have carriers, which can be either independent truckers, or companies that own these massive fleets of trucks. And the brokers sit in the middle and essentially try to pair up shipments to the available truckers. And until Convoy came along, this was mainly happening completely, totally offline, right? There would be somebody who had a phone and a little black book, and they'd get the order and they'd go down the list and they'd call people, and if they couldn't take it, they go to the next one. And so Dan and Grant, who created Convoy, essentially saw this like opportunity to build a marketplace, kind of like Airbnb or Uber, except for freight, and they're doing quite well. So around 1,300 employees, roughly $4 billion valuation, and the whole business, like our success as a company, is really built off our ability to use data, and that's because when we go to a shipper, like the Walmarts of the world, essentially the way that we win their freight, we have to bid on a freight that they have available, essentially, and then they pay us out, and then we provide an auction environment to the carriers, and then they bid on freight for us. The only way that we can really compete with a lot of these legacy players is by using data really intelligently. So that's like a bunch of machine learning models, experimentation, tons of business intelligence, to essentially say, how should we be pricing our freight? How is the market changing? when is a shipment going to be on time or not, and then we provide that data back to the shipper. And these are all, selling mechanisms for Convoy to win more freight, right? It's like, hey, Walmart, look at how much insight you have to where your freight is, whether it's on time or not, how much is it going to be, not on time by, et cetera, et cetera. So data really, really key to Convoy's success here. What we're going to be talking about today, which I'm very excited to dive into, is a little bit around, it's all about data contracts, but I wanted to set the stage of how we got here and talk specifically about the modern data stack and what that means to Convoy and what it's resulted in for our business. Some of the challenges that have emerged because we've invested a lot into the modern data stack without some foundational best practices, data architecture, things like that. And then how we're trying to rectify a lot of those problems through technology that is facilitating the best practices, right? That's kind of the goal here. Okay, so quick high level about data at Convoy and how we're using it. We use, like I said, we use data everywhere. Experimentation, if you're not familiar with A/B testing, it's like you deploy one version of your application to a small percentage of your audience, or maybe 50% of your potential audience, and you deploy another version of the application to the other 50%. You check some metric, maybe it's margin or growth or something like that, and then you see if there's significant differences between those two treatment groups. Machine learning, we're a huge machine learning organization. I think we have the 25 machine learning models in production right now, which is quite a lot. Automation as well. Obviously, huge parts of our app are data products. Essentially, I'm going to talk a little bit about a little more about those later. And then obviously we have sort of your typical, analytics and OKRs and weekly business reviews and things like that leverage data. So the team that I work on at Convoy is called the Data Platform Team. And our goal is to reduce the operating cost of Convoy specifically from the data side. But that's not, it doesn't just include the pure, compute storage cost. It's also, are we making the most efficient possible decisions? Our goal is to increase innovation velocity. So can we make better decisions over time faster? And can we also make sure that we're making the right decisions? So, high levels of trustworthiness and data quality. Here's a quick rundown of some of the tools we use. So I break it into 5 categories, which is actually, storing, basically where we store the data, how we move data between different systems, different tools for transformation and orchestration, data discovery tools. Some of these are in-house. It's stuff that we've built ourselves for a very specific use case. Chassis is a discovery tool specifically for data contracts. Explorer is a discovery tool for metrics. If you don't know things like Amundsen, these are more like data catalogs that sit on top of the data platform, and a few other things as well. So our team owns all of this. We're about a 15-person team, half data engineers, half software engineers. So we do a lot of buying things, a lot of building. It's a pretty large surface area. So we talk a lot on our team about the modern data stack. And that's because, I maintain more than just about any other team at the company, the data infrastructure organization really needs to think about the balance of speed and governance. Convoy is a startup, so they want to move quickly. They want to continually ship new products, ingest new data, build new pipelines, and do a whole bunch of wacky, zany, wild transformations and pipe that into dashboards and let executives and product managers look at them and so on and so forth. But at the same time, we're also not a small company anymore. So there is a need for governance, and there is a need for some semantic coherence and data integration. And we're always trying to weigh the trade-offs of both of those two things. Um, and Convoy has been a modern data stack adopter, which definitely leaned way more into the speed side very, very early on in our history. So we've adopted pretty much not every tool in the modern data stack, but most of the core platforms. You know, Snowflake, Airflow, DBT, Fivetran, Metabase, Tableau, and there's a few others that we've adopted as well. And we've been using these tools for years now. So we've completely rolled this stuff out. It is operating at scale, and that's been happening for a while. And we have a lot of battle scars that I think a bunch of companies haven't quite got to yet because they're still in that very early adoption phase. So I can kind of give you a preview of what's coming. The good thing about the modern data stack is that it is very self-service. It's super easy, right? You know, DBT, if you're not familiar with it, it's just a command line. It's all SQL. Lets people, you know, build these data models very seamlessly. It's not particularly difficult to learn how to do stuff, right? It's not hard to, you know, create a new or leverage a new Fivetran connector and plug it into some Postgres database and pipe that data somewhere. Like super, super simple. And when you're just starting off, it's also not that expensive. That changes over time as the complexity begins to emerge. But it certainly allows teams to move quickly. And I think what the modern data stack has been amazing at is getting those early stage companies from, you know, zero data infrastructure at all to some amount of useful data set, you know, something where a person can make a decision on data in a very short amount of time. But with the good comes the bad. And I think that there are some inherent challenges that are caused by just blindly adopting the modern data stack, which is exactly, you know, what Convoy did. And I can say this because I work there, right? One of the first major problems is modern data stack is very ELT driven. Yali Sassoon wrote an article a few days ago where he talked about the idea that seeing data as oil was kind of problematic because it assumed that you can just reach in and pluck all the great data out of the ground and then feed it into some destination, and then you write transformations on top of it and you're good to go. But we all know that that's not really how it works. If you want high quality data, you actually have to create high quality data. And a lot of the tools in the modern data stack do not actually facilitate this workflow very well. The other problem is that ELT and CDC, which we'll talk about a lot more, exposes the implementation details of databases, essentially. And this is really bad. Again, I'm going to get into this a lot more in a little bit, but just as sort of setting the stage here, there's very little centralized design, very little context or semantics on what the data actually means. Convoy still does not have a full-time data architect. You do have a lot of people, including myself, in some cases, like serving as a data architect and like doing data architecture, but it's not our full-time job. And I will never say that I'm talented at it at all, nor do I really have the skill set, but someone's kind of got to do it. And then you also have this like really weird evolution of the data model, I find, as teams will emit data from production, they'll pipe it into their own little sort of corner of Snowflake, and then they'll transform it a bunch of times. And then after that, they don't really care what happens. Other people might start taking dependencies on that data. Like I said, not a whole lot of governance. And so you get these silos of poor data quality that people don't even realize are being built. Oftentimes the right data is just not there at all. And the tech debt starts to explode rapidly, like exponential increase in tech debt after about, you know, the second year of us adopting the modern data stack and really lacking a lot of the you know, processes and sort of standards around governance. We saw huge increase in the number of DBT models. I mean, I think we increased from like 100 models in year 2 to like 300 in the second year, and now, you know, we're approaching over 1,000 data models. It is not something to be proud of, and it becomes really, really hard in that state of the world to then back your way into governance, right? Because you already have all the tech debt, the teams are already used to moving quickly, and coming in and saying, hey, we actually are going to start locking stuff down and we're going to implement RBAC and all this other stuff it's just a much more challenging conversation to actually have. So the place where we wanted / needed to go was more responsibility and more ownership on the data that was coming from production systems into our data platform. And the vehicle we wanted to use to facilitate that was a data contract, which is what we're the main subject of today's talk. We also wanted the semantic meaning of the data to be incredibly clear. We wanted the data consumers to actually be taking a role in the design of the data coming from production, but also in the design of the warehouse itself. We didn't want it to be one person sort of sitting in an ivory tower. This is something that needed to evolve continuously through rapid iteration, the same way that the code base has evolved in the software engineering world. Producers need to take ownership over quality. To me, this is a non-negotiable. And again, maybe we can talk about that more. But lots of other things that we wanted essentially. But the starting point was producers are taking ownership over that data quality, and there's a good relationship and collaboration between the consumers. So there's really 4 things that we thought were critical to making the lives of our data developers easy. And this was sort of our tenets or our guiding stars as we built out these solutions. The first was our business objects needed to be clearly defined. We needed great documentation, like what does this data actually mean in the universe? Ownership had to be super straightforward. And we needed to treat data as a product and not a byproduct, meaning it's not just digital exhaust that's coming off the back of these transactional databases. Like it's actually built for a specific high value use case. So this is sort of a funny post that I made on LinkedIn a few months back that essentially walks through, what is the life of the data developer at like your modern tech company. I'm not going to go through every step here, but essentially it's this back and forth process of getting asked to answer a question and don't know where the data actually is, and you got to talk to people. It turns out they left. Then you got to go speak to the engineer, and they don't really know what you're talking about either. And you have to do all this digging. And when you finally get it right and sort of parse through all the data after being, pinged constantly along the way, your query breaks, and you have to go through all these steps of validation. And then, there's no real exit criteria. It's like super vague. So you don't even know if you actually solved the problem. And then, the product manager who asks you just like immediately moves on to the next thing. It's just not like a really great process. And this was something that was, endemic at Convoy. So this was our setup. This is a very, very high level, and I'll have a deeper architecture in a bit. But essentially, the way things worked at Convoy is that we were collecting data from our backend services, and which includes our databases, and then also our front end applications. And we were using Mixpanel for that, and Mixpanel is an API, so you can use it for both use cases. We were not using it that much for backend data collection, and that's because it was hard. But we were using a lot for front end data collection. We would push it out to their SaaS platform in the cloud, and then we'd use Fivetran to then push that data into Snowflake. And then on the backend side, we basically would just pull all of it out of S3 and then use Fivetran to, again, dump it into Snowflake. And then we had that was more or less our lake. And a set of data engineers were, maybe 3 or 4 years ago, tried to create some core tables of, combining some of these like random things together, building out our, most critical business objects. But then like some weird ownership stuff happened because the data engineering team didn't really want to own business logic. They wanted to own infrastructure. And it was just super messy and resulted in a whole bunch of like nasty spaghetti SQL. And this is an image from Mehdi Waza. He wrote an article about data contracts. I really like this image because I think it pretty accurately represents the state of the world at a lot of companies, where you basically have super critical data for analytics and machine learning that's primarily being used for transactional, like operational use cases. Like it's like powering some functionality in the app somewhere. And the backend developer, oh, was there a comment or someone say something? No, I think those are just some pots clanging. Okay. So this is usually owned by the backend developer, but they are not, in most cases, they are not thinking about the data warehouse at all, right? They're just like, listen, I got my operational data and that's all I really care about. But a lot of these modern data stack tools, Fivetran, we essentially go into these Postgres databases, extract the data, pull it out, often without the software engineer's consent, and then we drop it somewhere, and then we do a bunch of transformations, and from that we do our analytics. And the problem is quite obvious here, right? Like when the software engineer who's generating the data doesn't know how it's being used, and nor do they care, it results in all sorts of changes happening upstream that then go on to break the downstream consumers, or maybe there's misunderstandings between like what a particular field actually means, and it causes all types of issues. So high level of our previous system is the producers didn't really take accountability for data quality. This absolutely was not their fault, right? There was a lot of non-consensual APIs where we're just plugging in these ELT systems to production tables. The producers were not aware at all of how their data is actually being used. So if you go to any software engineer at Convoy who's generating data and you said, hey, how is your data being used in Snowflake? Like what is the most important use case? They would have absolutely no clue. It's a complete black box to them. And because of that, it's very hard to understand what the data actually means semantically. And how the data essentially relates to each other is also not clear. You might have different teams generating like very similar data. You're not exactly sure of the relationship between data coming out of one service and another service because that hasn't been established actually. The source of truth, which should be our data warehouse, right, is not really a source of truth. It's just sort of a place where tech debt kind of accumulates. And then there's a huge validation cost to sort of untangle all of this spaghetti SQL, and it results in a lot of reverse engineering SQL queries to sort of infer when things should, like, basically we should be capturing things from our production systems for explicit use cases, but we don't have that, so we have to write SQL to get at those things. Like there's probably 30 or 40 tables in Convoy's Snowflake instance that are really just entities, which should be a production table somewhere. And so it takes weeks of work to do things that, in my opinion, should be like hours or even a few minutes in some cases. And so you're essentially left with a situation like this, right? Where you've got all these awesome tools, you've got, monitoring tools and BI tools and transformation tools and ELT tools, but the data itself is total garbage, right? It's a garbage fire, and that makes everything worse. The tech debt continually accumulates, and it doesn't matter how many tools you build, you're left in a similar situation with this sort of underlying data not being of high quality. Okay, so let's talk about solutions now. So the way that Convoy wanted to solve this was through a proposal that I called in a very, very, very unique name, Next Gen Data Platform. And the core of the Next Gen Data Platform model was the data product, basically. And the data product is a pretty new paradigm. And the idea is like these individual data domains should be treated as the equivalent of microservices. And we wanted to use an event-driven architecture in order to produce these data products. So a bunch of companies have started to implement this. The mastermind behind the data product concept is Zamek and Data Mesh, and she has an awesome book that I've read. So yeah, I love the concept of data products, and we wanted to sort of enable this at Convoy. And here's sort of a visualization of a data product, right? You've sort of got a domain, and within the boundaries of that domain, you've got the operational system, which is, you know, the source, the data source, the actual, you know, data product itself, like the data set and any associated data sets. And then, you know, the sort of input outputs that other teams can then take advantage of to build their own data products on top of. And you inevitably get something like this, right? Where you have one team that owns sort of the artist's data product, another that owns users or podcasts. And so instead of just looking at this big mess, there's very clear ownership. The boundaries on quality have been well established. The documentation is ideally like very good. We all sort of saw this and just unanimously like nodded our heads like, yeah, this is probably the world that we want to move to. So the sort of key points from the data product paradigm, at least my takeaways anyway, was data is actually a first-class engineering citizen. It's not just digital exhaust. You have semantic categories or domains that are very clearly owned and maintained by a product team or engineering team. The data is actually explicitly designed for high-value use cases, not just tossed over the fence and used for whatever. And the operational systems are decoupled from analytics and ML. And this is something that, you know, I don't know if this was explicitly stated, but it's something I strongly believe is that you actually do need to decouple these two systems because they're useful for different things. And then the product teams are not just responsible to, you know, to their own use cases, but they're actually responsible to consumers. And these are the contracts, right? Okay, yes, so we call this the next-gen data platform, and it's essentially a set of technologies and processes designed to facilitate a transition to data products. So high-level problems that we felt this new system solved: lack of a contract. We were only really capturing the data that was required by the production system for the transactional use case. We weren't collecting the data in many scenarios that the downstream teams actually needed to do their jobs, and that's what resulted in a lot of the, you know, reverse engineering. Right now, there was basically no collaboration, lots of complex SQL, spaghetti SQL, duplication, no ownership, et cetera, right? And the stance that we maintained was that science and analytics actually need to be first-class consumers of these applications. And the workflow that we had in mind was data consumers need to be the ones to define what they actually need to do their jobs via contracts. The service teams and the consumer teams then actually align and iterate on those contracts. And then the data that is vended is, you know, highly trustworthy. The software engineers are thinking in terms of data APIs and not just databases. And you have federated change management. So every team is responsible for their own change management process, CI/CD, version control, schema evolution, and so on and so forth. And then our other principle is that we wanted to meet teams where they are. And this is actually a really important one because Convoy is a very fast-moving organization. And what I can promise you, in fact, not just promise you, we tried to go the data mesh route in the beginning, right? We tried to sort of take this cultural approach, and it did not work. People asked, why should we do this? We have higher priorities. This seems like a huge effort. What do we get from this? We only have like 3, you know, business intelligence engineers, and we have other things for them to work on, and so on and so on. It was just a big, nasty battle. And our thinking was not everybody actually needs to move onto this paradigm at the same time. Some people can move now if they want it. Some people can move later. But we, as the platform team, needed to provide technology that made that transition very simple. Okay, so today, or at least the previous state of the world, analytics is an afterthought. No ownership, lots of gaps and duplications. Data warehouse evolves in a hyper chaotic way. And in this new system, we've got data as products, clear SLAs, great collaboration, and very obvious ownership. Okay, so let's talk about contracts. So what are data contracts? Data contracts are APIs. They don't necessarily need to be APIs, I suppose, but I think that thinking of them APIs is healthy. And there are agreements between the people who are generating the data and the consumers of the data around what is the data that is actually being produced for which use case, with a strong focus on schema at the core, the values of those of the schema, SLAs, and also the semantics of the data itself. So you might be thinking, well, that just sounds like a regular API, and like you are right about that. The term data contract to me has taken off, if you've sort of heard this in the discourse, because of its implications. And the big implications, there's a few big implications. One of which is that software engineers are used to thinking about how systems talk to each other, right? Like REST APIs, but they're not really used to thinking about their data that they put into a database, like data at rest, as an API. And in a lot of cases, folks think about APIs more as like an edict, right? Like, hey, here's a thing that I'm going to give you, and consumers, you can interact with this thing however you want, right? But that's what data contracts, I think, evokes in a lot of people, is that it's much more of a conversation and an agreement. Hey, I need something. I need you to put some enforcement around this thing that you're producing. And if we do this together, it will result in a better outcome for the business. And then sort of on more of a technical side, there's tools like change data capture and schema registry that are very helpful in actually bridging this gap from an implementation perspective. So 3 things that we're going to talk about here when it comes to contracts. The first is some of the different types of data contracts and their use cases. The second is how to implement a contract. And then the third is this thing that I've heard a lot that I just would like to address, which is like, this is a engineering cultural change. It's not actually a technology change. I completely disagree with that. I wouldn't say I completely disagree with that take. I think every major business change is like in some way a cultural change. But I firmly believe that if you provide really good technology, it makes the cultural change possible. Okay. And there we go. All right, so why do we see data contracts as the solution, or as at least one part of the solution to all these nasty issues that I was talking about a moment ago? Well, the purpose of a contract, it's in the name, is that it establishes a agreement and clear ownership on what is the data coming from production systems. It facilitates the development of data products, right? A contract you can think about like a product that usually has one-to-one semantic one-to-one mapping with some semantic concept. And then it also provides a single surface for collaboration. So instead of running to team A or team B and trying to get on their backlog and have conversations with Slack or talk to the person in person, you actually have like a well-defined surface where all these conversations can happen, and both sides understand how to interact with that object. So this is a pretty high-level view, a very simple view of how you can think about a contract, a data contract manifesting. So if I wanted a contract, for example, around an entity called truck, I might establish my schema, which could include 4 or 5 different properties. I lay out the data type, and then I would also lay out like what are the values of this particular property, and then what are the semantics associated with each value and each property. And I could do the same thing for a event, right? So like it's not a truck, but a truck arrived at a location. I specify the schema, et cetera, et cetera. I go through the same process. That is deployed via an API. Data is collected from some production systems. There is a validation enforcement, like abstraction layer, where essentially if the data does not adhere to the contract that was specified, there's some type of enforcement. In our case, we actually break the build, and then we push that data. We do it via Kafka into the cloud data platform, which is Snowflake. So the commandments of data contracts, these are good things to keep in mind when you're thinking about like what needs to be true in order to actually have a full, like a good implementation of data contracts at your business. The first is that data contracts must be enforced at the producer level. The sort of old saying here is that, you know, the handshake agreement isn't worth the paper it was signed on. So there needs to be some mechanism on the producer side to ensure that that contract is actually being followed. Number two is that the contracts are public. So, you know, this is a version control, really great change management, et cetera, et cetera. Like I said before, data contracts cover schemas. This is like sort of foundational, but it also covers semantics. So just like in any other like API, if the actual like content of that API, if the semantics of the API change from version to version, you can consider that a breaking change. So you know, for example, if I have a data contract where truck distance is expressed in miles, and then in the next version, it's now expressed in kilometers, even though technically the schema won't break because those are both numbers, but the contract has still been violated because it means something semantically different. Fifth, the contract should not hinder iteration speed for developers, meaning you shouldn't be adding, you know, significantly more work or new processes for your software engineers. And that means like getting into the CI/CD workflow, the same CI/CD workflow that they use today. This is that whole point about meeting people where they are. And then in the same way, the data contract should not hinder the iteration speed for the data scientists. So the data scientists and the science team and the analytics team, they still need the ability to iterate really quickly, right? They need to experiment with data, write a whole bunch of like random SQL to just, you know, sort of exercise their creativity. And we don't want contracts to slow down that process. Three types of contracts we're going to talk about. The first is paper contracts, which are sort of like conceptual data contracts or PRDs. The latter two are both code-based approaches to data contracts. Entity contracts, which leverages CDC or change data capture, and then event contracts, which use a pattern called transactional outbox. So a paper contract is basically a handshake agreement, which I know I just said is not worth the paper that it was signed on. However, I think paper contracts, if you are not able to make an investment in the technology, are a really good place to get started. So it's basically just going up to a producer as a consumer and saying, hey, can you pretty please take ownership over this stuff? I would really like for you to. And I hope that you don't break us because I have an important use case. So good things about paper contracts is that it's actually not bad for building an initial relationship between producers and consumers. I find a lot of times most of the talking that happens between software engineers and data people is only after a bad thing occurs, right? Like something was broken and now, you know, my model failed and I'm going to go yell at somebody, or there's a Sev 0 or a Sev 1. That's just not really a good relationship to have. What's a lot better is to go to the engineering team, get on their backlog, say, hey, here's the use case for this data that you're producing. It's really meaningful, and here's what I would need, you know, sort of on the monitoring and alerting side. I think just I have actually found that that certain engineering teams are actually pretty receptive to that if they're given time and it's not treated as like a, you know, house on fire problem. It's treating data as a product. Like I said, pretty good for actually building culture. And it's free, right? It's cheap. If you don't take into consideration the time it takes to get some of this stuff implemented, then yeah, it doesn't cost anything. However, there are some cons to this approach. Number one, the biggest one, is not actually enforceable, which means it's not really a contract. It's just an agreement. This is also extraordinarily hard, I find, for a lot of teams to prioritize because it's not clear to the software engineers how they would facilitate this change. It's seen as a very big management burden. It's way more work than they currently have to do. And so for that reason, they can be a bit gun shy on taking ownership over some of these data objects. And the other problem I found is that the consumers oftentimes don't even know which producer they need to talk to generate the contract, right? You might be several layers of transformation deep in your warehouse or whatever it is that you in your swamp, right? Whatever you want to call it. And at that point, like you don't even know who's generating this data, and figuring that out might take you on the order of weeks. But however, if you do want to move ahead with paper contracts, this is an example of the document that we used at Convoy before we rolled out our technical implementation. And there's a few things that sort of make a good data contract template. The first one is to specify the model semantics. And the number one question that I like to ask is, what does the row, what is the row of the data that you expect actually going to mean? In this case, it's each row represents a unique pricing request. That is super important, I found, for the software engineering team to understand how they should be vending this data in the most appropriate way. We also lay out for some table that's being created, that's built on this data, what are the semantics need to be? What are all the columns? What are the description of the columns? Is there anything special that you need to think about when it comes to validations? Like, is there any columns that absolutely can't be null? Are there columns where a certain value like needs to be filtered out, et cetera, et cetera. And then finally, laying out some of the SLAs, the latency, laying out the testing plan. We actually have a whole separate doc for what the testing plan should look like. My recommendation is, if you're going to go this route, make sure that you actually go over your testing plan with the engineering team, build it as a partnership. I've seen some scenarios where the data team came up with the testing plan based on what they thought was meaningful, and the software engineering team basically took one look at it and was like, yeah, we're not going to do those things because it doesn't make any sense. It doesn't seem like there's a great business validation for why we need to keep the null rate under like 0.5% or something like that. Okay, sort of moving on. So quick sort of summary, if you're using a paper contract, you want schemas, values, business logic, latency, testing, and validation. Also, looks like a comment came through that I just want to answer real quick because it's relevant. Want to clarify a question just to make sure I understand. Producers are the operation applications. Consumers are other operation apps or cloud data platforms. Is correct? Yep, that is absolutely correct. Producers are the transactional systems, and consumers are anything else. So it could be the data platform. It could be another service, right? It could be anything else. Okay. Okay, so let's move on to the more interesting point, which is entity contracts. So we're sort of going beyond just like pure documentation at this point into an actual code-based implementation. Entity contracts are essentially enforced nouns. So I like to think, just to establish what an entity is, if you're not familiar, in the freight world, it's like it's any object. So it could be shipment, shipper, auction, contract, carrier, customer, et cetera, et cetera. And then the properties of that object are like adjectives. So you might want to know whether or not a shipment is on time, its ETA, which could obviously change. You might want to know, its starting destination, ending destination, the facility it's going to, and so on and so forth. And the entity contract itself refers to the API. So this is the API that the producer actually generates that corresponds to that particular object, and is treated as part of a product and enforced through great, CI/CD and change management best practices. Okay, so why do we want something like this? Well, number one, if we have a data contract around entities, it means that our schemas are not going to break. And if they do, we'll know exactly who broke them. We might know why they broke them, and we'll certainly know when they were broken. And that's obviously something that you can investigate. If there's a SEV0, then you have all the documentation that you need to describe like why that issue occurred. It's also great because the data producers in this world are aware of what the downstream consumers actually need. So it provides a ton of visibility into the warehouse and any of the critical data sets that depend on this entity. And it's also it's easy to implement. So it's something that fits right into the software engineering sort of design pattern already. It doesn't require learning a brand new technology. And then it's also easy to iterate and sort of evolve these schemas over time. So some pros, number one, prevent breaking changes. Number two, it leverages CDC, which I'm going to talk about in a second, for real-time syncing. So, which is great because that means that you will know if a contract is violated in real time, anytime that violation occurs. And that's what allows you to actually, do the, push something off to a DLQ or something like that. It's a form of integration testing for the data warehouse, and it facilitates that. And then because it facilitates any other, it's an API, right? It actually happens like pre-warehouse, then any consumer can use this. So at Convoy, we have a lot of services that actually are using these contracts for various reasons. And then the final piece, which is quite important, is that it provides a layer of abstraction between the producers and the consumers. So we're not just vending the internals of a database to a consumer. The engineer has the opportunity to actually vend, a transformation instead. The two major cons are, one, it doesn't explain the context about why a thing happened. It only explains that a thing happened or that an entity changed. And then two, it's costly, right? Like it can be expensive infrastructure to implement, no doubt. A quick review of change data capture here. CDC refers to a process by which we are detecting anytime a row changes in a database and then pushing that change off somewhere else, essentially in real time. The reason we're using CDC for contracts is because, number one, it runs at the level of the data store. It's not in the application. So that means that every single, update that actually happens to an entity, you're guaranteed to get that. There are some other ways of doing this outside of using CDC, but CDC is like a very nice, clean solution, not that many moving parts. You're also guaranteed at least once delivery, so you know that you're never going to lose any updates, which is great. It provides an audit trail. So if you want to see how an entity has evolved over time, which is incredibly useful for debugging, among other things, it's really valuable for that. I find engineers love using sort of the audit logs of entities for debugging purposes. Like I mentioned already, it's real time. It has this like real time syncing mechanism, so it's pretty ideal for detecting, stopping, and pushing contract violations off somewhere else. And then it also allows you to send event data through Kafka, which means it can be leveraged anywhere in the business. At Convoy, we actually just released a feature maybe a few weeks ago now that it was built entirely on top of data contracts. What was the name of that feature? It was something like oh man, I'm having a brain fart. But it essentially was showing the customer, the shipper, the status of their shipment at any point in time, and it relied on several of these these like real-time CDC events. It's great. It's got a lot of rave reviews. Okay, we have another question here. CDC typically implemented. So the way that we implement it is using something called Debezium. Debezium is an open source product, uses it's a functionality called the write-ahead log. You essentially, it basically sits in between the, here it is. It's actually here on the, I don't know if you can see my mouse, but it's in the, it's in the lower right side of this architecture diagram here. So when an entity changes, you get this transaction log. This is the write-ahead log that I was talking about. It pushes that change out to this sort of Debezium product, and then Debezium has some connectors. It does have sort of a Kafka system, and then through Kafka you can then push the data, wherever it is that you want it to go. In fact, I think Convoy built the Debezium Snowflake connector. So yeah, little fun bit of trivia there. But yeah, so we use Debezium, but there are other ways of implementing CDC. So this is sort of how we think about the whole system for entity contracts. On the left-hand side, you've got your contract definition phase, which I will talk about. Then you have the actual CI/CD. This is the enforcement. And then you have fulfillment, which is how do we now get that data, push that data from one place to another place. So like I said, three pieces for the definition phase. Really, as long as you have strongly typed schema, it doesn't really matter what system you use. There are open source, great sort of open source products that do this quite well. Protobuf is what we use at Convoy, but you can use JSON, right? There's nothing wrong with that. On the enforcement side, there's really two main things that we think about. It's backwards incompatibility checks for the data contract itself, meaning if we modify the contract, is that changing in a way that is backwards compatible? So if someone is, removing or changing the name of a field in the contract itself, and for that we use Kafka's the Kafka schema registry. And then we do integration testing locally to check if the contract is actually being fulfilled. Is the data that we're sending over matching, what the contract says it should be? And then on the fulfillment side, I already mentioned CDC. This is a pretty important point, which is to provide a abstraction layer between the database and its destination. And that's because you don't want to consume these raw CDC events directly. So we use a stream processing layer for that, KSQL specifically. And so the engineer writes some relatively simple KSQL query that maps to the contract, and then they vend that. And that basically abstracts the consumer from having to know, from basically getting a copy of a Postgres table in the warehouse. All right, so that's entity events. The second and final type of contract is the application event. The application event refers to a change in the state. Oh, this is actually backwards. Oh no, yeah, it's backwards. Whoops, looks like there's some wrong text here. You can think of it as a verb, not a noun. So this is when a behavior, some entity completes an action in the real world. So for example, a shipment gets canceled, or a shipper maybe signs a contract, or a contract is fulfilled. These are point in time events. What we really care about, it's almost like adverbs. We care about metadata associated with the context of when that event happened. Like, what was the reason that someone canceled, right? Like, that's the type of important data that we want to record. And that's not going to come from a database update. It's going to come from somewhere in the code itself. So application events can be a little bit more complicated to implement because it requires understanding the service. And in many cases, software engineers don't actually understand their service. This might be because it was implemented by someone that came before them. It could be just a relatively junior person. It could be a monolith, right? And there's all types of like crazy, wacky things happening there. But application events can be extremely powerful when the software engineer knows where that data is and can easily go and get it for you. So pros to contracts around these application events, really a lot of the same things as the entity events. Basically, it provides the best layer of abstraction because it is a complete decoupling of the database and the actual analytics and machine learning use case. And that complete decoupling is obviously great for a lot of reasons. Like, it's a true API in every sense of the word. The con is, like I said, it can be pretty costly to implement, from the sense of you have to go out, figure out like where this data is emitted. Sometimes it might even be emitted in multiple places. Like, this is something that probably deserves, its own slot on the backlog. So the way that we implement these application events is very similar. So I'm giving you a real example. This is so Convoy has an internal IDL that we call Philo, and we're basically in a lot of cases now we're starting to leverage Protobuf. But you can see first you define the actual event definition, which you see here. Then we have a event publisher. That event publishing code gets auto-generated. So all of like the boilerplate we handle for people. We have compile time schema checks. We do backwards compatibility checks. And then if something is backwards incompatible, then that's when we fail the build. And then we run a pattern that's called transactional outbox, which essentially ensures that if an application event occurs, that there was a corresponding database change. And only in those situations, it's either an all or nothing. Only in that case will we actually, push it to Kafka. And then finally, on the fulfillment side, we basically have a pretty simple method where we just say, publish event name here, and then within 5 minutes of the code actually being deployed, then you can consume the event, and it's in the lake. But with transformations on top of it, it's in the warehouse as well, because it's real time or near real time. So in a universe where you have both of these types of contracts, right, you actually have something that looks like this, where all the real world behavior that corresponds to a status update to an entity is covered by the entity data contracts. So, shipment statuses, carrier statuses, tender statuses, all that's handled through contracts, and it's getting pushed into Snowflake. And then all the real world behavior, all the things that these entities do, are handled by the application events, and those are also going into being pushed into Snowflake itself. And both of these together form that like data product that we were talking about at the start of the presentation. It's clearly owned by the software engineering team. That it follows, great CI/CD best practices. And if it does break, then there's change management and there's accountability in place as well. Okay, so coming into the home stretch here, but you might see all this and go, wow, this is really great stuff. Awesome technology, seems so cool. But how do I get an engineer to actually care about this? That's a good question. I think about contracts at any company as a maturity curve. The place where most organizations are is off the scale, right? There's not really a lot of collaboration between the data team and the engineering team. The engineering team, as I said before, doesn't really know how the data is actually being used. Oftentimes, they're only approached by the data team when something breaks, or the data team might be asking for something and the software engineering team doesn't understand like why they need to generate that data. They don't understand why the data scientist or analytics engineer, whoever, can't just go write DBT and generate this. So the first step into solving this problem is actually awareness. And awareness means the data developers and the engineers being on the same page in terms of how the data is being used and what the semantic meaning of that data actually is. That's like a whole problem to solve. Next is the ownership problem, meaning once I, as a software engineer, am aware who is taking a dependency on my data, how important is that, and what are the SLAs that they need, now I'm either willing or unwilling to take ownership over that data set. And in most cases I've seen, software engineers are actually incredibly willing to do this. Next is the API or the abstraction. If you're a software engineer and a bunch of people have taken out contracts on your data, you don't want to do that, right? Like you don't want to be accountable to multiple consumers. You want to emit a single API that all these consumers use. They all use the same thing, and this provides a really great incentive to move towards the abstractions that I was mentioning about before. And then finally, you get to rules. So these are things like, what is a appropriate percentage of nulls on a particular column? And that's what needs to be mapped to business impact. And it's always going to be a seesaw, right? Software engineers are probably going to think it's going to be one thing, but as data teams learn more and more use cases, they might think it's going to be another thing. But if you've already done the steps that come previously on the curve, you will have that relationship in place and you'll be able to have those conversations, which are not really occurring today. I want to talk tactical. How do you actually implement each one of these steps, and how do we do it at Convoy? So like I said, awareness is, data producers need to be aware of how things are being used and the impact of breaking changes. And if they don't have this, then the whole thing, the whole shebang is a black box. The problem that's being solved from the perspective of the engineer here is that they do not want to be on the hook for Sev zeros and Sev ones for business critical data assets. Machine learning is obviously a huge example of this. Financial pipelines is another. Business critical dashboards that go in front of the CEO, those are others. And then just naturally, software engineers want to know who has dependencies on their data. That's kind of an important thing to them. So three sets of solutions here, from simple to advanced. The first is you could just go through by hand and literally essentially like create a lineage yourself, right? You should say, hey, this is the table that's meaningful to me. These are all of the upstream tables that are like impacting this downstream thing. I'll put it in some centralized place, like maybe Notion or Microsoft, Google Docs or whatever it might be. And then go to the software engineer and say, hey, like, look at this. This is how the data is actually sort of being leveraged. Now, to be fair, oftentimes these things can be pretty hard to parse, and it may not be that conducive of a conversation, but is a step in the right direction. The second piece is to have the CI/CD workflow actually essentially giving tooling to the software engineering team so that they can trace the table level lineage of their changes in that CI/CD workflow. So they're able to say, hey, I'm making a change to some property. It's going to impact this table downstream. And here's everybody who leverages like that table to solve some business use case. That's a little bit more automated, but as people listening can probably assume, some tables have massive blast radius, right? So it is still putting the burden on the software engineer to go and sort of one by one figure out everybody who's going to be impacted, and that's a huge lift. The ideal solution, and this is the solution we have implemented at Convoy, is column level lineage. And that column level lineage starts at the contract, which is a request on top of the downstream data set. So the way that it works at Convoy is that if you are a data consumer, you have a YAML file. You can add that YAML file to a central repo where you say, I have some properties, or I have an entire table that needs to be under contract. We will run column level lineage in reverse up through the data warehouse to the source tables. And then we will take out a PR against those source tables and say, hey, this person downstream has asked you for a contract. Here is what that contract is. That's where we supply all of that sort of metadata in the YAML. Here's what the contract is. Here's how the data is being used. You can look at it yourself. You see who the actual owner is. You can reach out and talk to them. And even if they don't accept that contract, if they do make a breaking change, we will still surface it in the CI/CD workflow as a warning. We have seen this be tremendously effective as just getting the software engineering team aware of like what is the stuff downstream that people care about. Step number 2 is the actual ownership of the contract. Is the ownership, which is the implementation of the contract itself. So the contract, to me, especially the entity contracts, are a way to stop the bleeding, right? It's a way to say, hey, I'm getting broken today. I'm getting low quality data today. I might want to go get the ideal data at some point in the future, but like right now, I just need to make sure that like the data that's coming from these source systems is quality. And obviously the why on that is if you don't have a contract, then there's no guarantee that these production pipelines like won't change in unexpected ways. And if they have ownership, then it allows the software engineer to actually make the best decisions for the data that they're on the hook for, which they really don't today. So 3 solutions here. Great. See you later, guys. And almost done. Wrapping up, folks. The 3 solutions here. The first one is you can just do all of this, totally manually, paper contracts, like I said. The second solution is you define data contracts in code, and you validate against the schema registry, and you break the build if the contract is violated. And then the third step is you actually generate the entire pipeline based on the contract data, and then push it into your lakehouse, validate it before it arrives. And there's a bunch of things that you could do there. Next, data APIs. So APIs is the abstraction layer. The reason why this is super critical is that a data producer could get really overwhelmed having to support a lot of different contracts for different teams that may even be contradictory from time to time. The problem that's being solved is that if you're a software engineer, you want the abstraction, right? You want to decide how you bend this data down to a consumer. You don't want to be, locked into the thing that you were specifically asked for. There might be a better way of implementing this data that your consumers don't even know about. So two main solutions here. The first is that they have access to this sort of entity or application event abstraction layer that I described before. It's a complete decoupling. And then the other option is you have a stream processing layer, and the decoupling happens there, which is also really great, meaning that we can just write some SQL and instead of having to go into the service code and implement all of these events. So after you have a system like that, where do you go next, right? What's the next step for data quality? You can do catalogs. You can have single definitions of conformed dimensions hosted by a service. This is actually what we're working on right now, which I'm really excited about. Contracts at the warehouse level. So that means from consumer to consumer, I own a table and I'm vending some data to someone else who owns a table. Really smart monitoring and so on and so forth. So here's an example of a small piece of some of the contracts that we've implemented at Convoy. The names of the objects are on the left. The service that's generating the data is in the middle, and then the actual entity is on the right. We have hundreds of contracts rolled out at Convoy, with more being generated every single day. This is happening entirely organically, meaning I'm not going around and like beating teams over the head with a stick to try to get them to do this. It's actually very helpful for them. Engineers want it and data people want it. We've got thousands of contract modifications. There's all this like really great conversation about the data that was just never happening before, which is personally my favorite thing to see. The fragility of a lot of our models are decreasing. So we've actually measured, the percentage of nulls is going down in some of our most important models by an order of magnitude. And then we're also mapping the semantics, because when these contract requests are being generated, we're including like, what is this object and why is it important? And so teams can discover all of that, and presents a totally new a new vehicle for them to discover how the business works and what data is dependable and what is not. Okay, so last slide. A few big takeaways here. The first one, contracts, really, really important for production grade data pipelines. You can implement contracts through culture, but technology makes adoption really much simpler and more likely. It's an act of collaboration between producers and consumers. The abstractions make it way easier for the data consumers to ask for what they need and for data producers to provide them what they need. And the goal is on the definition of semantics in production systems, not just accepting all of the cruft and the nasty implementation details that we get from databases today. That's it. Thank you, man. What a journey.
Awesome. Thanks. Let's open up the questions here. Let me see here. Just put it awesome. Yeah, good presentation. Dave Richards, you have typed in a question, but maybe you just want to ask instead.
Yeah, I was just wondering, how long did it take for people to, I mean, this is amazing. I'm looking at the after effects, but how long did it take for people started catching the vision and getting excited on their own?
Yeah, I'm not gonna lie to you, it took a while. So I came up with this approach in 2021, so like Q1 of last year. It took us through the middle of that year to get some of the foundational technology in place. We had a full quarter where we were trying and failing to explain the value of this to people. And then we had thankfully we had a few engineers that got it. They implemented it as our design partners, and then they just raved about it, essentially. Like, so we got them to go on like an evangelism tour to the entire company. And we did that. We did like this whole evangelism tour for an entire quarter. And then at the end of the year, our CTO felt it was so meaningful that she asked every team to take a goal of implementing, like they basically had to talk about like what they were doing for data quality for the year in their quarterly and yearly planning. And obviously we recommended implementing contracts. So it's taken, I would say, like we really saw the contract starting to take off in Q1 of this year. We had about 200 implemented, and it's just been kind of an exponential curve ever since then.
Wow.
Good question. Hanley, you also had a question here. I don't know if you want to just ask Chad. It's in the chat there.
Oh yeah, so I was just curious if there's any specific data quality issues that you've seen at Convoy, might be semantic, maybe not, that you feel solvable by contracts, which you guys are doing, versus ones that are still aren't quite there in terms of being able to be solved by contracts?
Yeah, that's a really great question. So I think anything that breaks, like we had a ton of issues, like a ton of problems that just would have been solved like by having some form of integration testing. Like, hey, I dropped a column because the software engineer didn't think that they needed it anymore, and it turned out that that was not true. people did actually need it. We've also seen like the issue of nulls is one of the biggest data quality problems for our machine learning models. Some of our really critical models have like really high numbers of nulls, meaning that we have to drop, like, in my opinion, unacceptable amounts of data, like 20% to 50% of the data gets dropped. And that has been one of the biggest problems that this has solved. It does in a lot of cases require some investigation on the part of the engineer, but like it's still it's still a lot more more lightweight and iterative to investigate, like, why is a single column, you know, why are there a lot of nulls on a single column than, you know, trying to do like a massive refactor or something. And then there are some semantic issues. Semantics, I would say, is the piece that we have explored the least, and we have the least tooling amount around right now. We're going to be getting to that in the next few months. We're rolling something out, and there's another article coming that's based on sort of how we built it. So I wouldn't say that we've really effectively solved that problem for now. In terms of what are the data quality issues that it doesn't solve? I mean, I think that it solves like pretty much any problem that's caused by, you know, the producer to consumer. It's just good conversation, and like good conversation, in my opinion, like solves most problems. So the issues that our specific model doesn't solve is like, well, what happens when you're already in the data platform, right? Like when I've built a table called bi.shipments, and I built it for my use case, and now 3 other teams have taken a dependency on me, and then I've quit the company and I've gone somewhere else, and that table is just totally neglected. We don't solve that problem at all. So that's like one of the first things that we always get asked is like, oh, this is awesome, it's great to have these, you know, these checks in place from production, but like, what do I do about about the rest of the data? So yeah.
Awesome. Thanks, Chad.
You're welcome.
Ben, you typed a question here. I don't know if you want to ask it.
I have 2 questions. Thanks for the presentation, Chad. The first one is around how long did it take to get the full MVP A to Z for one data contract? And then how many people were involved, both from engineering and data engineering team? Then the second question, it seems like in the CI/CD process today, if there is a break in the schema or the contract, the CI/CD won't pass deployment. What do engineers do today in order to deploy a new change in their database or schema? Do they have to deploy the contract first? Yeah, those are the 2 questions. Thanks.
Yep, sure. So for the first question, how long did it take us to get to an MVP? We got the MVP, our first MVP out in about, it was just under a quarter. And in terms of how many engineers we had working on it, it was one. So we basically had one software engineer that put together the library for pushing the contracts out to schema registry, and using sort of our IDL to define the contract. Like all that was one engineer over something. It was like maybe four sprints, something like that. We've since added we've done more MVPs since then. So we did one on a column level lineage, and building in the contract sort of request mechanism, like that. I described that whole, you add a YAML file to a repo, we go up the graph. That took us, that was one engineer, 2 weeks. So it was about a sprint to get that out. And then it was about a month with 2 engineers working on the stream processing abstraction layer. So and when I say like these are MVPs, like these are true MVPs. Like our goal, the goal that we have as a team is just to build stuff as fast as we possibly can, get a design partner really quick, validate it, and then go back and harden it later. Essentially just prove the idea, because the things we're doing are like relatively newish from a technology perspective. And then your next question on what do engineers do if there's a blocking change? Well, I mean, they can just override it, right? That's an option. Although that doesn't look very good for them. So one thing that we're missing that we would like to add is alerts, so that if a blocking change is essentially overridden, then we tell the downstream consumers like, hey, just be aware that like a change is about to come to you, and here's who did it, and here's what it was. No one has actually done that yet though, so fingers crossed for the future. But generally what happens is the engineer will just go talk to whoever has the contract, and it's usually a pretty easy conversation. In fact, I haven't actually even seen that many. I think there's maybe been like 3 or 4 that I know I've personally been brought into, and I was mainly brought into it just because it was the first time, and the software engineer was like, what do I do? I've never done this before. And in most cases, the answer was like, okay, you're making a backwards incompatible change. Here's how our data is going to be affected. And the software engineer went, oh, okay, I didn't realize that. I guess I'm just not gonna, I don't think I need to make this change then. Yeah, like it was resolved actually quite simply.
Yes, one follow-up. Thank you. One follow-up question. You said that the engineer will go to someone that owned the contract. Does this mean that the people that own the contracts are only on the data side in the company, or also engineers?
I'll rephrase that. Own is probably a bad word. It's more like the data, the contract essentially is like a handshake that things are not going to change between these 2 groups. And so they're really just going to like one half of the contract owner and saying like, oh, listen, in a lot of cases, they didn't even know that there was a contract. Like I would say 50% of the time, it was more junior people working at the company that like were not aware of the history of the contracts and like what was put into place. And so they went and reached out to the data scientists, and data scientists said, oh yeah, here's sort of the context for all this. We have all the records, right? Like the requirements are kept in the catalog so that they can do a review. I think in one case, a senior engineer was brought in, and it was all resolved pretty quickly. So it is joint ownership, definitely, but sometimes the engineers who are actually making the changes were not, in the loop when the contracts were built.
I guess I have last question as a follow-up. You also mentioned that you have kind of like growing amount of contracts. Now at the hundreds, who knows if it's going to get to the thousands. You also have a ton of changes.
Yes.
Do you manage a version control of the changes, and then do you have any plan or mechanism to make sure that if someone is leaving the company, etc., you manage the ownership of the contract?
No, we do not. No to both. But those are absolutely things that we want to do. So this is on our backlog for next year, is to like, there's a lot of depth to this that I didn't obviously I didn't talk about, but like one thing that we observed is that it takes sometimes the iteration time can be quite long for contracts. So engineers will emit events. There'll be like a V0. Sometimes the data team will, like, because it's not actually versioned, then the data team will consume those and they'll like start doing validation on them, and they'll say, wait, I'm not ready yet. Then they'll do the validation and some things need to change. And then they'll decide like, oh, wait, we're starting to get some nulls. We didn't expect that. We need to roll out a new version. So part of our goals for next year is to make that sort of iteration process really simple. And when one of those initiatives is to version all the events, all the contracts, and all the columns, and then make it really easy to do backfilling and that type of thing. We do have a backfilling mechanism today, but it's not the easiest thing in the world to use. And then your comment about informing like when somebody rolls off the company is also quite salient, and I do not have a solution for that right now, but I agree that is something to be considerate of as well. Like that whole sort of process around change management, right? Like there was a reorg, and the team A now is responsible for contracts 1, 2, and 5. We don't really have a system for addressing that yet.
Thanks, appreciate it.
What other questions people have? Or comments?
Hello, yeah, I've got a question. So I am one of those probably more junior engineers that Chad, you were talking about earlier. And I'm just kind of trying to understand what a data contract is and kind of how it's added value to your company. So if I'm understanding correctly, previously upstream engineers would make changes like delete a column or whatever, and that would heavily impact like the more downstream like data science sort of stuff. I guess what does it look like now whenever that upstream engineer would delete a column or something? Would they get like an error, or would some like how do they know that they're not supposed to make that change?
Yeah, that's exactly right. So when they're going through their CI/CD workflow, we would break their build, so they wouldn't actually be able to push that change. And then we would give them an error. We'd say, hey, the reason that we broke your build is because there is a contract in place between your organization and this downstream consumer. And then I mentioned lineage. If you're not super familiar with data lineage, it's basically a mechanism of crawling through your cloud data platform and understanding how like upstream tables are connected to downstream tables. So we give them a vehicle to not just go out and figure out who to talk to and see what the contract was and when it was put in place and the context around it, but actually go to the table itself, see how it's being transformed, along its like path to the end destination. So those are like the three things that we provide. And the most common outcome is just a conversation, which is what we want, right? We want these teams to be talking to each other, and that's right now today they're not in most organizations.
Awesome, thank you very much.
I will add another question, if that's okay. You talked only on kind of like streaming mechanism, both CDCs and Kafka, etc., event stream.
Mm-hmm.
Did you also consider or doing contracts for batching? And then if so, I guess not just for batching, also in the initial implementation, did you go all the way back and kind of like check the data for its history, or just started from some point in time and say, let's start contract from that moment and on?
Yeah. So we did not actually think about it for batching. And the reason we did not in our case is because we had already transitioned everything except for our third-party 5-tran integrations to Debezium. So we were already running on CDC anyways. So yeah, we did not do that. There could be other models that I've yet to investigate for fulfillment. In fact, I'm sure that there are. We did do backfilling and validation on historical data. This wasn't handled by me. It was actually handled by the science teams. Yeah, in some cases that was quite extensive, essentially doing the mapping and like ensuring that like, you know, the last 6 months or 8 months of data coming from Postgres lined up with, you know, like the new data. Yeah, it was, in some cases it was tough. When it came to the CDC streams, it was pretty easy because in most cases it wasn't, our first implementation didn't even have an abstraction. It was just like, here's the existing stream, here's a contract on top of it, like don't break it. And when the transformation did happen, like there, in some cases there were a few issues. I think the longest one, I don't have a specific example off the top of my head, but I do know there were some science teams that were working for a few weeks on actually, you know, getting the new data to conform. So backfilling is definitely like a major part of this that I did not dive too deep into, and I probably should have now that I think about it in retrospect. I just had too much content for you guys.
You mentioned that you in 5-tran specifically, you did not implement contracts. Do you plan to do that with like third party or move off third party, or any idea of doing it with third party or thoughts on doing it with third party?
Yeah, we've thought about it. I've been noodling. I still don't know what an ideal implementation there would look like. I think there's probably some interesting stuff that we could do by, you know, having like a test sort of landing zone for data coming in from a third-party application, push it there, run a check. If it doesn't actually meet the contract, then I don't know, we get rid of it, or we push it off to another table or something like that. And it's only if it passes that it actually moves to the real lake. That's one way I've thought about doing it, but I mean, to me, the sort of heart and soul of the contract is like, it needs to be a agreement. It's about causing the conversations to happen. And if you're applying it on something coming in from a third party, it's really just more of a validation. There's nothing wrong with that. I mean, I think that that's a great thing to do, but it's not really the spirit of what I've been trying to implement for the past couple of years.
Got a question for you. So
Sure.
yeah, DBT just announced the semantic layer and DBT core. Thoughts on semantic layers?
I don't know, man. I haven't dived. I haven't gone in too deep on what they announced. I have some hot takes on the semantic layer.
Yeah.
Oh, do you want me to go?
Yeah, go there. Yeah, please.
Okay. Well, first of all, I think the name is wrong. I don't think it's a semantic layer. To me, semantics, you know, semantics are about like meaning, and the semantic layer that I've seen proposed are more on these like logical derivations of things. And so like right away, I already have a problem with the term, and I've gotten yelled at by a bunch of people in semantic layer for like apparently like using that word incorrectly. I think conceptually it's not a it's not a bad idea, but there's a big governance process there that I wish folks would pay a little bit more attention to. Like there needs to be a lot of thought into like what is the actual like CI/CD experience around creating a metric or creating an attribute, and who owns it, and like what's the contract around it, and like I think all of these things are actually are really, really important. Like just having a vehicle to do transformations and having like a YAML file where you can describe some like metadata about like what a metric actually means, to me is not incredibly useful. What I was imagining is if you have this system of contracts in place for your production data for the real sort of semantic layer, then it actually becomes then it becomes a lot easier to build this downstream logical layer on top of the contracts, right? Because then you can say, okay, I have this thing called a shipment canceled event, and I know that this shipment canceled event maps to like the shipment entity. And so I have like, there's like a set of transformations that I can reasonably apply to this like shipment canceled event. And now I have like a single, I don't know, it's an IDE or something else where I can write that SQL, and that transformation belongs to me, and I can vend that, I can now vend that metric to the rest of the company, and like I have a contract. So that's the way that I see it. Of course, this is very like biased, but like I kind of imagine it as contracts all the way down, you know, like turtles all the way down. But if you don't sort of start off with that upstream ownership and clarity, I don't see how semantic layer could ever. It just seems like you're just sort of moving the mess from like
Yeah,
one
I
place.
tend to agree. I come from a kind of a lean background, and it seems like, you know, you want to try and you know, address the problems at the source, not like, it's kind of like doing quality control at once something's at like the source you know, kind of back room, and it's about to go out the shelf. It's like, that's a bit
Yeah.
weird, but I guess so. But better to address that when it's being made. So yeah, totally agree.
Yeah, no, I mean, I 100% agree. It's sort of, it kind of feels like this whole data stuff is kind of being done backwards.
Mhm.
Like we've kind of, and I think sort of venture capital had a big part to play there, right? Like people really got excited about dashboards and business intelligence because that's the thing that added value, but we didn't, we kind of moved away from like the concept of an integration layer for data. And so you're just left with all this like messy stuff in dashboards. And then we move to the transformation tools. And like now we're moving to sort of metrics, and it's just continually like pushing the tech debt like further and further up for somebody else to deal with. Doesn't seem like the right approach.
I agree.
I think the concern is that you're going to end up the same with models. Like you end up with ton of models. You're going to end up with ton of semantic layers, duplication, etc.
Mm-hmm.
I don't know how you wouldn't. I mean, the
Yeah.
first time I saw this was Looker way back in the day with LookML. I would argue they're probably one of the first modern semantic layers, but and it allows you to kind of repurpose definitions, but that didn't mean that you couldn't duplicate a definition on accident. There's nothing to stop you. So I think it was a good, but basically what it was doing is taking basically the notion of ORM code and shoving that into a data paradigm.
Mm-hmm.
That's what happened.
Mhm.
So if anyone's programmed in Rails or Django or whatever, it's basically the same thing.
And the definition doesn't propagate, right? Like if you have the metric in different
No,
models,
it
it will
wouldn't.
not propagate down from the source. So yeah.
No,
same.
in fact, the same problems I see with all this stuff going on right now, that modern data stack is the same stuff I saw with ORMs and web frameworks back in the day. It was, I mean, it allows you to do stuff quickly, but you know, there's speed and there's rigor, and these are not, these are often opposing forces. So.
And I think what you said is really important, Joe, because there's at least what I've noticed about the modern data stack, and I was kind of mentioning this at the beginning a little bit, is that it like it seems like the rigor has basically been totally thrown out with sort of the most recent crop of tools, and I think that's almost like a what's the word? It's when you go really sharply in the opposite direction. And you know, like we had, you know, a huge amount of rigor when you're, well, not a huge amount, but you know, when everything was like very process oriented, there was like a ton of rigor, and you know, you had human beings that were essentially acting as like the bottlenecks to all the data coming into the company, and they were using these very specialized tools. And companies like roundly rejected that, and they got super excited about just being like, oh, everybody can load data into the cloud and anybody can do it and anybody can write transformations and we can move 1,000,000 miles an hour. And now I think, I don't know, I see it very similar to sort of DevOps and the emergence of GitHub and how like what seems like the ideal model is iterative governance, right? Like you actually want to be able to set a governance paradigm from day one, and there should be some incentive to do that. Like even if I have 3 software engineers working on my team, like there's still governance in place, right? Like we still say, hey, you know, we don't push something into production unless there's at least like 1 reviewer on a PR, right? Like that's a form of governance. And then as the number of engineers we hire get larger and larger and larger, like that governance model expands sort of naturally and organically with the company. And that's the piece I think is like missing from data today.
For sure.
Yes, I think Todd is on the money. Governance and guardrails, not gatekeeping.
It's absolutely true. Todd's also always on the money. He's one of the smartest people I've met in the data space or tech space in general. So, Todd, do you have any questions? Just gonna call you out here. I know you always have something to say. So,
no, I think it was a great presentation, and there's a lot of things to cover in this space. I do like that we started out basically saying, yeah, this is data products and data mesh, and that's kind of important. I think this is the right direction. It's definitely like a decentralization. Like you're not at your company, the data team doesn't seem like it's in the way on everything, and that's ideal. And I don't think you called that out enough, but that's what I saw. And like people are fairly autonomous, and that's the way it should be, and you should be proud of that.
Thank you. That was you're right. You're exactly right about that. And in fact, like the reason that this whole initiative got started was because our engineering manager, he was the engineering manager and the data engineering manager for the team. All the data engineers at Convoy were originally, all except for like 1 or 2 that were working on the centralized infrastructure. They were embedded in product teams, and they reported up to data science, and their life was basically a living HE double hockey sticks. At least that's what we heard from them. So they all wanted to move to the centralized team and work on like Snowflake and Airflow and DBT, and then they did that. But of course, like then all these like product teams were left kind of, you know, just holding the bag, right? Like they're like, yeah, we don't know how to do this. Like we don't know anything about data architecture or pipeline development. Like we build models and run A/B tests and those types of things. And so that went on for like 3 months, 6 months. And then the data scientists were knocking on my door saying, hey, we're going to need those data engineers back now. And I was like, okay, well, that's not going to happen. So we're going to need to find another way of doing this. And that's sort of where this model kind of came from. It's like, listen, you actually don't need us in the loop if, you know, the people generating the data are in the loop and like they care. And then the goal is to just sort of incrementally work our way down, right? Until the data consumers themselves are having conversations with each other on the data that they want to vend. That's ultimately where we want to get to.
On that subject, my question would be, where do you see the biggest holes in the tooling to make that easy for everyone?
Yeah, on the latter part, right? Like you're talking about on the like the contracts within the warehouse.
Oh, I'll leave it open. Just anywhere in the process to build autonomy and good behaviors, like those guardrails are usually tools. And
Yeah.
like where do you in your world see the biggest gaps?
Yeah, so I see there's a bunch. So I think a lot of the technology that we've built, it mainly uses open source components, but we're kind of duct taping things together. So that's not great. Then within the warehouse, there's just nothing, right? You've got tools like Great Expectations and Datafold, which I think are pretty cool. But it's not quite the same as contracts, right? It's more like, hey, here's what I'm expecting, and here's what I think the data should look like. And if it doesn't look the way that I want, then the tool is going to tell me, but it's not going to stop the other person from doing the thing that they're already doing. And similarly, like Datafold could say, hey, here's a diff, and like you're going to break somebody, but do they care? But like, has the conversation of ownership actually happened yet? No, in most cases. So yeah, I think there definitely needs to be some tooling there. The way that I have thought about this is that, I don't know, this is the hypothesis I'm testing at Convoy, and I'm probably going to be wrong about it, and I'm going to look like an idiot sort of saying this publicly, but my thinking is you actually don't need explicit ownership in order to take out a contract within the warehouse. Like you technically, I guess you technically don't even need it for the sort of databases to the warehouse. But anyway, but the thinking is like you could essentially run this lineage thing that I was describing before, say, hey, here's the data. You could take out a contract at sort of every level of transformation in the pipeline. And then you pretty much have two states of the world, where one state is someone comes in, they want to make a modification to a table, like change a column or something. And it's like, hey, are you the owner of this? If you are, then you're going to get the decision to decide like what happens here, right? So if yes, you can either reject the contract or not, but then you're going to be accountable for it. And if no, then you don't need to make the change. Like you don't get to change something that you don't own. And the motivation for, I think that would actually create this, like, it would actually incentivize the move to data mesh, because what people would then do is they say, well, this table, we have a lot of these at Convoy where it's like maybe 30% of the data is coming from my team, but 60% is coming from somewhere else. So I'm like, I don't want to own this entire thing, but I do own like these 3 columns. So I want to be able to change those and iterate over those for my use case. So I'm just going to create a new table with only the stuff that I own in it. And then I think there needs to be some way of like moving the contract onto this like newly owned thing, is my thinking. Which is very early, but the goal there is to like incentivize people to componentize these very nasty, like essentially unwind all the spaghetti SQL, and do it in a way that's like doesn't like particularly block the things that they're trying to accomplish in their day-to-day lives. That's like a big thing that I think is missing, and I have literally done like nothing to actually solve that problem yet. And then the last thing I'll say is I think there needs to be a solution more tailored towards semantic monitoring. Like there's like some monitoring tools that exist today, right? Where you can adjust some thresholds, or you can kind of see how the data has changed over time. But there needs to be some way to be more specific about this, about like on the changing semantics, and then have some mechanism of like pushing that to an on-call backlog. Hey, like it's not just that something changed and people should be alerted, it's that this particular change is now worth engineering investment, and there's a threshold, and we need to be able to specify what that threshold is. That doesn't really exist either from what I've seen.
It'd be pretty cool if it did, though.
Yes.
I imagine it's difficult to like have that context in a tool when it's not like a standardized kind of, like your example of miles and kilometers. Like,
Right.
How would you automatically tell without building a whole lot of business logic into the thing checking? And
Yeah,
Well,
exactly.
And it's one of those things where it might require more energy than you'll get out of it. You know what I mean?
Mm-hmm.
It's sort of like this weird like law of thermodynamics for semantics. So it's interesting though.
This is also where I kind of disagree with the DevOps mentality of shift left everything. This is one area where look, when this breaks, you're going to notice it further down the pipe, and that's okay, because noticing it earlier in the pipe is no more valuable than a few steps down.
Yeah, I agree with that. Yeah, it wouldn't fundamentally change anything. In fact, it could actually make the conversations more difficult in some cases because the engineers probably don't have as much context as the data people.
Very much so, yeah.
Yeah. Yeah, I think there's I think there's probably like a whole set. I was talking to Gleb from Datafold maybe a month ago, and the way that I was thinking was that like, honestly, I think there's a whole set of tools, even outside of this, that doesn't really exist right now that I would love to see. But I sort of look at the modern data stack, at least like the current incarnation of it, kind of like they facilitate building pipelines for prototyping like really well, right? Like you want to get something up fast, you want to just understand the data, you want to like write some simple, not even simple, but you want to write some like quick transformations and visualize it. Boom, great, that's awesome. But if you want to actually have this be trustworthy, and like we have a shipments object that is used by every single team in Convoy, like that actually needs to have a different sort of, it's a different thing. Like it needs a different set of validations and tools and structure. It actually needs to be like, built well and high quality, and all these sort of things around like, oh, having data diffs and having expectations. To me, that's where it makes sense. Not just trying to layer on quality stuff into spaghetti SQL world. What I've found is like at Convoy, we barely use DBT tests at all. And it's because you write a test and it's going to fail a million times a day, and you're not going to know why. Like it could just be some wonky thing that happens, like, oh, the job didn't run on time, and now I have a test failure that I have to go debug, and I have no context on whether this is important or not. Like, is it even going to sort itself out? And then if something does fail that you don't own, it's like, okay, well, what do you do about that? Like something happened upstream. Does that mean I have to go yell at this person to fix it? Like, are they going to fix it? I don't know. And so a lot of these tests just go totally ignored. And then our team was complaining like, oh, why doesn't the data team write tests? It's like, well, that's why. It's because they don't do it's totally
Because it's
pointless.
the wrong layer and the wrong control mechanism.
Yeah.
Awesome.
Yeah, I agree. Modern data stack is a really bad.
Well, I mean, it was all marketing from day one, right? So, I mean, which many phrases, but it's funny how it captured the public imagination, and there's a whole conference going on actually right now about it and all that fun stuff. But I don't know, it is what it is. So vendors will vendor. So yeah, cool. Any other questions, comments for Chad? Or thank yous? We can give him a round of applause. Thank you very much for the awesome talk and Q&A. This is actually one of the better Q&As we've had in recent times. I think it's very forward thinking, and not that they're all not forward thinking, but this one in particular, I think it hits on. Well, I mean, what you're doing, Chad, I think it hits in the zeitgeist of kind of where things are right now, and I think that the many possible futures for where things go, and I think you're sort of at the forefront for thinking through this. So that's really awesome, and I'm excited to see what happens next. So,
well, thank you, Joe, for having me. This has been awesome.
Anytime,
I've loved talking to you guys. Feel free to connect with me on LinkedIn. I'm always up for just spend an hour talking about random data things. So
yeah, he is on LinkedIn. Are you on Twitter?
I am not on Twitter.
Okay, cool.
And I think people know I'm
man.
not on Twitter, and so they say they say things that they probably shouldn't say. I'm sent screenshots on like a weekly basis on some stupid thing somebody said on Twitter.
Oh, interesting. Oh, that's pretty funny. Let me stop recording real quick, and then we'll talk more about that. All right, thanks everybody. You can catch us on YouTube.